Your laptop is off, your phone is locked, you're asleep, and your AI is at work. It is reading your emails, pulling deadlines from your calendar, drafting a document based on a meeting that ended 3 hours ago, sending a follow-up to a contact you forgot about, and organizing a project tracker in Google Sheets, all without you touching a single button. That is not a pitch for some hypothetical product arriving in 3 years. That is what Google just announced is available right now, today, in 2026, for anyone with a Google account and the right subscription. And the reason this moment feels so different from every other Google AI announcement of the last 4 years is because this time it is not a chatbot. It is not a suggestion engine. It is not a fancy autocomplete. What Google just unleashed across Google AI Studio and the broader Gemini ecosystem is a full agentic runtime, a system that reasons, plans, executes, and completes real-world tasks across your digital life without requiring you to watch it happen. The scale of what this enables is genuinely difficult to process all at once. So we're going to go through it systematically, every major piece of it, because the sum of what just landed is one of the most significant AI infrastructure moments since ChatGPT went public in late 2022. Let us start with the centerpiece of everything Google announced at I/O 2026, which is Gemini Spark, because Spark is the product that makes all the other pieces make sense. Google unveiled Gemini Spark at I/O 2026 as an always-on personal AI agent that can receive tasks via a dedicated Gmail address, browse the web through Chrome, and work around the clock without requiring users to keep a laptop open. Read that sentence carefully, because every word in it matters. Always on. Receive tasks via Gmail. Work around the clock without your laptop open. This is not a description of a chatbot you interact with. This is a description of a system that operates independently, that has its own inbox, that runs on Google's infrastructure rather than your device, and that continues executing tasks in your digital life whether or not you're paying attention to it. Spark is not a new model. It is an agent, a persistent runtime that runs on dedicated Google Cloud virtual machines, stays online continuously, and takes autonomous action across your digital workspace. The technical architecture of how Spark works is worth understanding because it explains why this feels qualitatively different from previous AI assistants. The original Gemini assistant was stateless. Send a query, receive a response, session ends, extensions. And function calling added the ability to invoke tools during a conversation. But each interaction remained bounded by a request lifecycle. Spark breaks that model entirely. When you ask a stateless AI to do something complex, it does that thing in the context of your current session. And when the session ends, the context is gone. You have to re-explain everything next time. That is a fundamental limitation that makes stateless AI useful for individual tasks, but nearly useless for anything that requires continuity across time. Spark solves this at the infrastructure level. It maintains goal state across hours and days. It can monitor your inbox on a schedule, cross-reference incoming emails against deadlines you described weeks ago, and draft responses before you have even opened. Gmail that morning. The session never ends. Google describes this as long horizon execution, the capacity to maintain context and pursue goals across extended time windows without losing track of where it is or what it was supposed to do. Spark connects workspace tools like Gmail, Docs, Slides, and more, working as a cloud-based agent. It does not need the user's device to stay active all the time, as it processes tasks in the background, even after the user closes their laptop or locks their phone. The demo that Google showed at I/O illustrates how this works in practice. Someone asked Spark to help plan a block party, and it went and created an RSVP tracker in Google Sheets, populated it with details from Gmail, and sent follow-up reminders to people who had not responded yet by itself, while the person was doing something else entirely. That single demo captures the entire value proposition. The user stated a goal. Spark determined what steps were required, identified the relevant information from Gmail, created the necessary document, and took action, all without the user specifying each individual step. That is not automation in the old sense of the word, where you define a rigid sequence of rules and the system follows them. That is reasoning. That is a system looking at a goal, figuring out what achieving that goal requires, and executing the necessary steps with judgment. The privacy and security architecture of how Spark handles all of this access to your most sensitive data is something Google has addressed directly. Each Spark task runs inside a fresh, ephemeral virtual machine on Google Cloud that is torn down after task completion. User credentials are fully encrypted and never directly exposed to the agent. All agent traffic routes through Google's Agent Gateway, which enforces data loss prevention policies. Google also confirmed that Spark asks for your approval before it does something with real consequences, like sending an email or making a purchase. That approval gate is important because the question of how much autonomy to grant an AI agent doing real-world tasks on your behalf is genuinely difficult. And Google's approach here is to keep humans in the loop for irreversible actions while allowing the agent to operate freely on preparatory and organizational work. Spark is under your direction. You choose to turn it on, and it is designed to check with you before taking major actions on your behalf. It is not autonomous in an unconstrained sense. It is autonomous within boundaries that you define, which is exactly the right design philosophy for something operating inside your inbox and your documents. Now, Spark does not run on just any model. Gemini 3.5, Flash delivers intelligence that rivals large flagship models on multiple dimensions at speeds you have come to expect from the Flash series, being 4 times faster than comparable frontier models. It is Google's strongest agentic encoding model, yet outperforming Gemini 3.1 Pro on key benchmarks, Terminal Bench 2.1 at 76.2%, MCP Atlas at 83.6%, and leading in multimodal understanding with Charshiv at 84.2%. The benchmark numbers tell an interesting story because they show a Flash tier model outperforming the previous Pro tier model across the categories that matter most for agentic tasks: coding, tool use, multimodal reasoning. That is a significant inversion. Historically, the distinction between Flash and Pro was speed versus capability, with Pro being the more capable, but slower and more expensive option. Gemini 3.5 Flash. Pricing sits at $1.50 per million input tokens and $9.9 per million output tokens, roughly 40% below Gemini 3.1 Pro on both dimensions, with performance that exceeds it. You're getting better performance at lower cost with faster execution. That combination is not normal. That is the kind of leap that happens when a company redesigns not just the model, but the hardware it runs on simultaneously. Google DeepMind engineered these models from the ground up using purpose-built AI infrastructure. And this unique co-design of the model and hardware allows them to train deeper reasoning capabilities faster and more efficiently with every new generation. The hardware side of this story is worth pausing on because it explains the performance numbers in a way that the model architecture alone does not. Google announced TPU-8i at I/O 2026, delivering 80% better inference performance per dollar compared to the previous generation, optimized specifically for high concurrency agentic workloads, exactly the use case that Gemini Spark and the Managed Agents API create. When you're running thousands of persistent agents simultaneously, each maintaining its own state and executing tasks across hours or days, the infrastructure cost of doing that at scale is a direct function of inference efficiency. The TPU 8i improvement means Google can offer Spark and similar agentic products at price points that make them commercially viable for a broad user base, rather than just enterprise customers with unlimited budgets. Let us move to what this means specifically inside Google AI Studio, because this is where the developer side of the story gets genuinely exciting and where the practical use cases become concrete for people building applications. The Managed Agents API lets developers create hosted agents through a single API call. Agents that can reason, use tools, and execute code with all infrastructure managed by Google. The significance of single API call cannot be overstated if you have ever tried to build an agentic system from scratch. Historically, building an agent that could reason, call external tools, execute code, manage its own state, and handle errors gracefully required assembling a complex stack of components: an orchestration layer, a state management system, a sandboxed execution environment, error handling logic, retry. Mechanisms. It was weeks of engineering work before you even started on the domain-specific logic of what you actually wanted the agent to do. One API call now launches a full agent inside an isolated Linux container. The agent can reason, call tools, execute code, and persist state across multi-turn sessions. It eliminates the need for custom orchestration infrastructure. That is a compression of weeks of work into a single function call. And for developers building on top of Gemini and AI Studio, this changes what is feasible to build in a weekend versus what required a dedicated engineering team. You can now spin up an agent that monitors a data source, processes incoming information, applies reasoning to classify or respond, and takes action, without building any of the underlying infrastructure. The business logic is your contribution. The plumbing is Google's. A new built-in tools and function calling combination feature in AI Studio makes it possible to use Gemini's built-in tools alongside custom function calling tools in a single API call. This dramatically expands what developers can build without stitching together fragmented workflows. The built-in tools that Gemini 3.x supports include Google Search grounding, Google Maps grounding, file search with multimodal support, code execution, and URL context. Each of these was previously a separate capability that required its own integration work. Now they compose. You can build a single agent that looks up real-time information from the web, cross-references it with location data from Google Maps, searches through uploaded files, executes code to process the results, and returns a structured output, all within a single unified API interaction. Grounding with Google Maps is now supported for Gemini 3 models going forward, allowing developers to bring real-world geospatial context directly into their AI workflows. The use cases for location-aware AI grounding are broader than they might initially seem. An agent helping plan an event can now pull real information about venues, distances, travel times, and local businesses, rather than relying on its training data for location information that may be outdated. An agent processing customer inquiries that involve physical locations can now anchor its responses to current, accurate geographic data, rather than reasoning from stale, embedded knowledge. Any application that involves the physical world, logistics, travel, retail, real estate, food, and beverage becomes significantly more capable when the AI model can query live geospatial data as part of its reasoning process. A new multimodal embedding model was also released in AI Studio, supporting text, image, video, audio, and PDF inputs and mapping all modalities into a unified embedding space. This is a capability that developers who work with mixed media content have been waiting for. Previously, if you were building a search or retrieval system over a dataset that contained documents, images, and video, you needed separate embedding models for each modality and a custom layer to reconcile the different vector spaces they produced. A unified, multimodal embedding model means you can embed everything into the same space and run semantic search across all modalities simultaneously. A query can surface a relevant PDF, a relevant image, and a relevant video clip from the same search operation, ranked by semantic similarity in a shared representation. For knowledge management, for content discovery, for research tools, the applications are immediate and obvious. File search in AI Studio has been updated to support multimodal search, allowing native embedding and search through images using the Gemini embedding model. Grounding metadata now includes media IDs for visual citations and page numbers indicating where information is found. The combination of visual search and precise citation is a significant improvement for anyone building research tools or document analysis applications on top of the Gemini API. Previously, you could search documents for textual content. Now you can search for visual content, charts, diagrams, photographs, figures, and get back not just a match, but the exact location within the source document where that visual content appears. For legal tech, for scientific research, for financial analysis tools that process dense PDF reports, this is a meaningful capability leap. The coding automation story is where Google went the furthest at I/O 2026, and it connects directly to everything being built in AI Studio. Jules, Google's asynchronous coding agent, is now generally available. Assign a task, Jules runs in an isolated VM and returns a pull request. It runs on Gemini 3.1 Pro for paid tier usage and Gemini 3 Flash for the free tier, competing directly with GitHub Copilot Workspace and Anthropic's Claude Code. Jules is designed for the same general category of autonomous software development that we have seen emerging across the industry. You describe what you want built or fixed. The agent goes away and does the work in a sandboxed environment and comes back with a result you can review and merge. But the integration with Google AI Studio means that developers can extend Jules with custom tools and custom context, building specialized coding agents for their specific tech stacks, their specific repositories, their specific code quality standards. CodeMender is Google's automated vulnerability scanning and patching tool, requiring no manual triage, attacking the remediation bottleneck in enterprise security. This is a use case that has enormous practical value and has been consistently underserved by the existing security toolchain. Vulnerability detection has been automated for years. You can run a scan and get a list of vulnerabilities, but the remediation step, actually going in and patching the code, has remained a largely manual process. CodeMender applies agentic automation to close that gap. It does not just find the vulnerability, it writes the fix. That shifts the security workflow from humans, triaging a list of findings and writing patches, to humans, reviewing a list of proposed fixes and approving them, a fundamentally different workload that scales differently. Google Workspace Studio, which reached general availability earlier this year, introduced a no-code agent builder where end users can create automation agents simply by describing what they want in plain English. A user can say, for example, every Friday, ping me to update my tracker, and Gemini builds the automation. Agents in Workspace Studio can reason through problems and adapt to new information, tackling complex workflows such as intelligent prioritization, support issue triage, smart queue, approvals, content generation, and sentiment analysis. The no-code aspect of this is as important as the AI capability itself because, historically, the people who most needed automation were often the least equipped to build it. A marketing manager who spends hours every week manually compiling campaign reports from Sheets data, summarizing them in docs, and emailing them to stakeholders could benefit enormously from automation. But previously benefiting from automation meant either learning to code or convincing an engineer to build something for you. Workspace Studio removes that barrier entirely. Early adopter Karcher, working with their Google Cloud partner, used Workspace Studio to automate its internal product planning workflow by deploying multiple agents responsible for brainstorming, feasibility analysis, user experience validation, and documentation. Using the agents helped the company reduce manual planning time by as much as 90% and produce ready-to-review plans in minutes instead of hours. 90%. That is not a marginal efficiency gain. That is a workflow transformation. The tasks that previously required live meetings, scattered notes, and manual consolidation across multiple people are now handled by a chain of specialized agents, each focused on one part of the problem, each feeding its output to the next agent downstream. Alpha customers executing more than 20 million tasks using Workspace Studio agents in a single 30-day period gives you a sense of how quickly adoption accelerates once the barrier to creating agents is this low. In enterprise deployments, Danfoss, the Danish industrial manufacturer, automated 80% of transactional decisions in email-based order processing using Google's agents, reducing response times from 42 hours to near real-time. Suzano, a Brazilian pulp and paper company, built an agent with Gemini Pro that translates natural language into SQL queries, cutting query time by 95% for 50,000 employees. These are not controlled demos. These are production deployments generating measurable results at scale. 40 hours down to near real-time for order processing. 95% reduction in query time across 50,000 employees. The productivity numbers from real enterprise deployments validate what the feature descriptions suggest. This is not incremental improvement. It is a different order of magnitude. The Gemini API changelog also shows Lyria 3 music generation models arriving in AI Studio, both a 30-second clip version and a full-length song generation model, alongside Veo 3.1 Lite Preview for cost-efficient video generation designed for high-volume applications. The addition of Lyria 3 and Veo 3.1 Lite into the same API ecosystem where text, image, code, and data tools already live means developers can now build truly multimodal applications. Not just applications that handle multiple input types, but applications that generate across multiple output modalities simultaneously. A single application can take a text brief, generate a document in Docs, create an accompanying image with Imagen 4, produce a short video for social distribution with Veo 3.1, and generate a music bed with Lyria 3, all orchestrated through the same API infrastructure, all within the same agent workflow. Gemini Spark is also integrated with Gmail, Docs, Slides, and other Google Workspace tools before expanding to third-party applications through the Model Context Protocol during the summer of 2026. Google's use case examples include recurring bills, synthesizing meeting notes, or automatically generating documents from emails. The MCP expansion is the piece that takes this from a Google ecosystem story to a general computing story. Model Context Protocol is the emerging standard for how AI agents connect to external services, and once Spark supports MCP broadly, it becomes a general-purpose automation agent that can operate across not just Google's own products, but any service that exposes an MCP interface. Spark is already extended via existing Gemini Enterprise connectors to Microsoft SharePoint, OneDrive, ServiceNow, Salesforce, and Zendesk. This means organizations that run mixed environments, some Google, some Microsoft, some Salesforce, can deploy Spark across their entire stack, rather than just the Google portion of it. The Gemini app now serves more than 900 million monthly users across more than 230 countries in over 70 languages, up from 400 million at last year's I.O. That growth number is the context that makes all of the technical announcements land differently. A company doubling its monthly active users in 12 months and simultaneously shipping the most significant agentic infrastructure in its history is not running two separate strategies. The user growth and the capability are feeding each other. More users means more demand signals for which automation use cases matter most. More capability means the product becomes more useful and attracts more users. The flywheel is running. What Google has built across Gemini Spark, AI Studio, the Managed Agents API, Workspace Studio, Jules, CodeMender, and Gemini 3.5, Flash is not a collection of individual features. It is a coherent infrastructure for the agentic era, a stack that runs from the hardware layer through the model layer, through the developer tools layer, through the consumer product layer, all designed around the same central idea, that the most valuable thing an AI can do in 2026 is not to answer your questions, but to complete your goals continuously in the background, across the full breadth of your digital life. The question of whether you trust Google with that level of access to your work and your data is a legitimate and important question that every user and every enterprise needs to answer for themselves. But the question of whether the technology is now capable enough to do what it claims, that question has been answered in production deployments at scale with real numbers. It is capable. The age of AI assistants that wait to be asked is ending. The age of agents that act is here.